Okay, so we're live. Um, we let's start by going through the questions to do with differentiation. Right. There's something I want to show you. As we're going to be going through our questions. So what we are doing, the questions we are doing are for something that we call calculus. Okay. The questions that we do are for something called calculus. Are we together? Um, what should I call you? Give me a name for me to call you when I'm live. When I'm live, I'll call you R squared. So, calculus means differentiation and integration. Let's, and I want to just remove some misconceptions that you may have, and we get it out of the way. We do questions. So, for us to say, remember that the picture is like this, ma'am. This is the picture. You have differentiation here, okay? You have integration here. Now, for differentiation, for you to say you're good and you can do a lot of questions, this is the whole picture of differentiation. The first thing you have to know is how you differentiate the 5 types of functions, right? You remember, you should know how you differentiate the 5 types of functions. This is ln x, so y equal to ln x, the logarithmic one. Then the inverse trig, you only have to know one. Y is tan inverse of x. You should know how to differentiate it. Then you should know how to differentiate a, which is algebraic. For example, y equal to x squared plus 5, or let's say the 2x to the 3 plus 5x squared minus 9x, whatever. This is a polynomial, an algebraic term. You should know how to differentiate it. You should know how to differentiate the 6 trig functions, and you'll be given the table in the exam. You should know how to differentiate y equal to sine x, y equal to cos x, y equal to tan x. You should know how to differentiate y equal to sec x, y equal to cot x, and y equal to cosec x. All these you're given in the exam as a table. And you should know how to differentiate y is e to the x. This is the first thing that you should know when you're differentiating. Then you should know, okay, it's like you want to know the whole picture of differentiation. The first thing is the 5 types of functions. How do you differentiate each one of them? How do you find dy dx? Then, when you know the 5 types of functions, it goes to the next level now. You now need to know how to do the product rule. Okay. You now need to know how to do the quotient rule and why you need to know it. Okay. And how to do the chain rule. And there's a video where I explained all this. So I'm going to be using this in questions today, right? Product rule, we said you will be now having functions multiplying each other. Isn't you have seen the 5 types of functions? Product rule, you use it when you now have a function which is harder, where you have 2 of these 5 multiplying each other. What is the derivative of, um, let's say, ln x sine x? Okay, you have the logarithmic, the ln x here, multiplying a trig, which is sine x. So you should know how to differentiate when they multiply. And this is an example. And you should know how to use the quotient rule, which is when the functions are now dividing, right? ln x over sine x. You should know how to differentiate this. Are you seeing? Then you should know the chain rule, which is when you say ln of sine x, when one is inside another. This is the third. Now, when you know this is not the end of the day. You then need to know how to do parametric, how to differentiate parametric equations. How do you differentiate parametric equations and implicit equations? Are we together? All right. So parametric equations, these are equations that cannot be represented by one equation. So basically, you'll be having it like this. For example, let's say it says y is equal to 3t squared minus 9. And then you have x being equal to 2t minus 5t cubed. Then they ask you to find the derivative. Derivative is dy dx. But if you see here, for you to find dy dx, you need y and you need x. But you don't have them here. Let me move this. You don't have y in terms of x. For you to be able to find dy dx, you need to have y being equal to something x plus something. But here it is in terms of t, which means you can only find dy dt. And here x is in terms of t, which means when you want to differentiate, you'll be finding dx dt. These are what we call parametric equations. This is the situation that you'll be having. But you must now know that if you have dy dt and if you have dx dt, to find dy dx, it is now dy dt times dt dx. This is how you find dy dx. It is dy, remember you want y at the top, so it will be dy dt. But then you want x at the bottom, so you flip this. So it will be dt dx, so that x goes in the bottom. It's almost like so that the dt's can cancel, but you are not allowed to cancel them. But this is what you do. Well, you don't have dt dx. So this is just the game that you must know. You must know two steps to say, number one, this is how you get dy dx. By saying dy dt times dt dx. But now you will see that you don't have dt dx. This is the next step which you must know. You must know two steps. How do you then get dx dt? Because dt dx, because you have dx dt, not dt dx. So what you would then do, you would then say dy dx is dy dt times dt dx is 1 over dx dt. So if dx dt is 5, it will be now 1 over 5. If dx dt is whatever, you just say 1 over that, then you multiply by dy dt, you will get dy dx. This is what you must know about parametric equations. Are we together? This is how you differentiate them. You will be having parametric equations are equations that are not in terms of each other. Two equations used to represent one thing and they are not in terms of each other. So this is what you'll be having. Okay? Right. Right. Now let's move on. We now want to see what is implicit equations. You're also going to get them. So here what I'm giving you is the whole picture of differentiation. Everything you will be needing to do when you're doing differentiation. Are you seeing it? R squared? Are you seeing it? Good. It is, you should know the 5 types of functions. The table is given in the exam. Product rule, quotient rule, chain rule, they are shown in the exam, but you must know how to use them. Then you go to parametric equations. Then you go to implicit equations. That's the next thing you must know. As you know the whole of differentiation, the whole picture of differentiation. Implicit now, you ask me, what are implicit? Because you're going to be asked to differentiate them. You will be asked to differentiate them. So the question would be, what is it? What are implicit equations? These are, and so when we say something is explicit, it means you can put it in terms of y. If you say it's, for example, y is 5x cubed minus 9x squared plus t plus x. This is an explicit equation because you can make y the subject. When you have an implicit equation, even if I give you $1 billion, you can't make y the subject. For example, if you have something that says y squared minus 5xy plus y cubed x squared, whatever, this is equal to 0. I'll give you all the money in the world if you can make y the subject here. It's impossible. Do you understand? You can never make y the subject. It's mixed up. It's jumbled up. So you can't make y the subject. But you say, hey, wait a minute. So then how do I then get dy dx? Because I need to differentiate. Because I'm in differentiation. I'll be asked to differentiate this creature. Well, you are going to differentiate it in this format. Because it's impossible to make y the subject. So you're going to differentiate it in this format. I will show you the tricky parts. I'll show you where people make mistakes because we're going to meet it in the exam. But I just want you to know what an implicit equation is. It's different from a parametric. Have you seen implicit? To say implicit, it means you cannot make y the subject. Are we together? So you differentiate it whilst it's like this without making y the subject. Yes, we are going to have to. We're going to have to differentiate it. So this is the picture, students. You have the 5 types of functions. You must know how to differentiate them. Then you should know how to use these. The product rule, when the 5 types of functions are multiplying each other. Okay, 2 of them. Quotient rule, remember that, ma'am, and everybody. There is no product rule and quotient rule in integration. These things are ending here. Integration has its own methods. This is ending here. This is ending here. So you'd say, oh, hi, Ella. I'll tell you where you use it. The quotient rule is used now when they're dividing. You get 2 functions dividing like this. You had them individually. If you get them dividing, then you're going to use the quotient rule. When you get them dividing each other. When you get them multiplying each other, then you use the product rule. You let one be u, one be v. Just like here, you also let the top be u, the bottom be v. Then you're going to continue from there. Here, you have the chain rule, which you use when one is inside another. Sine x is inside ln. Then we have parametric, where we said you get 2 equations for parametric. There will be 2 equations, and you're going to have to do the chain. You're going to have to do the chain to get the derivative of your parameter. You get equations, then you're going to have to go in 2 steps. These 2 steps must be there. Step 1 and step 2. This is what you must master. If you say you know parametric differentiation, then you must know these 2 steps here. To say you will not have dy dx, but you need it. So what you're going to first do, you will find y is in terms of t, so you find dy dt. X is also in terms of t, so you find dx dt. Then you now say to get dy dx, the one you actually want, it will be dy dt, but times dt dx, okay? Times dt dx. But you don't have dt dx, you have dx dt. So you will now show now that dt dx can be 1 over dx dt. 1 over dx dt is dt dx. Then you can find your dy dx still. That's parametric. For implicit, I'll teach you. These are equations where you cannot make y the subject. There are too many y's, and the y's are doing different things. So you can't make y the subject. So If you cannot make y the subject, you're going to have to differentiate without making y the subject. That is what we call implicit equations. And you must know how to differentiate them. I'll show you where it's tricky, where people make mistakes in this type. I'll show you. But you must at least know what it is. Then, lastly, you now have the last part. Can you see this r squared? The last part is now application, application, application. So this is the most important thing, because remember, you are not preparing for a class test. You are preparing for an exam. Exams bring you the last part of things. So in an exam, what they'll do, if they want you to differentiate, they won't just give you implicit equations. They won't just give you parametric equations. They won't just give you things multiplying each other. They won't just give you functions from the table. No, they won't. They will ask you to find something that you can only find after differentiating. They'll ask you to find, for example, the stationary point. They'll ask you for stationary point. We are expecting it. The question will ask for stationary point, or the question is going to ask for gradient at gradient of a curve at a point, okay, at a certain point. Or the question is going to ask for, if it's not gradient of the curve, then the question may ask you to find, it can ask you to a lot of things. Rate of change, okay, we'll see if it asks for that. It can ask you to find equation of tangent. It can ask you to find equation of normal. But all these things, you can only get them after differentiating. That's why we taught you differentiation first. The first part is to differentiate. Then you now start the application, finding these things. Are you seeing this? Ru? R squared? So these things, the reason we learn differentiation is, yes, they are going to ask for them, but don't worry about finding them. That's application. The first thing you must find is dy dx. Then you can do the application. Let's look for questions, shall we? Let's look for questions. Look at this. We are expecting what we talked about. We are expecting. We are not being surprised. They are not surprising anybody here. The question says, find the gradient of the curve. The only way, look at this, we wrote it. The only way to find gradient of a curve is by differentiation. So they are actually asking you to differentiate. This is how they will ask you. They'll ask you to find something here. But remember, the only way to find that thing is by having the derivative first. Find the derivative. Then you can apply it. Are we together? So our biggest job is to find the derivative. Let's find the derivative. We know that's how they are going to ask us. So start preparing now. They will not say differentiate. They will say find the turning point. Find the gradient of the curve. They are asking for dy dx. And look at this equation, people. What type of an equation is this? Can you make y the subject here? Can you make y the subject? No, you can't. Right? So this is an implicit equation. Do we all agree? This is an implicit equation. So let's see how we differentiate implicit equations. Right, so here this is xy squared plus ln of x plus 2y is equal to 1. This is our first example. For implicit, let me tell you where it's hard. Listen closely and don't let me down. What you must know is that when you are doing these type of equations, where you cannot make y the subject, when you're doing this implicit equation, what you must know is that X and Y are treated as functions. This is where it's hard. X and Y are treated as functions. So the same way we had ln x as a function, sine x as a function, this is the same way we treat these guys. They are functions and they are different functions. Let me see if you know what, if you can remember what we said. If you have y is ln x sine x, how do you differentiate this? What should you use here? What should you use here when you are differentiating y is ln x sine x? What should you use, students? You must use the product rule, right? Because they are multiplying each other. Is it true, Ru? Because we have this first function and we have this second function and they are multiplying, so we can see it. So the only way to differentiate is the product rule, because product rule is used when two functions are multiplying. Now, remember we said x and y are functions. So that means here we have product rule again. So when you are differentiating here, you must use product rule. This is where a lot of people get confused. They don't treat x and y as functions, but for implicit differentiation, they must be treated as functions. So they are treated as functions. So when you are differentiating this xy squared, you have to use the product rule. Let's differentiate it. So what you're going to do is you put a big derivative outside to cover everything. Xy squared plus ln of x plus 2y. Then this is going to be equal to 1. We are going to differentiate the whole thing. Now let's start using the product rule carefully. This is where the secret lies. This is where this thing is hard for people. They don't use product rule here. Product rule says this is u, this is v. So when we want to differentiate it, how do we differentiate? How do you use the product rule? You must now know. Product rule says when you are differentiating, remember, we are differentiating everything. So product rule says bring the outside, y squared, that's the v. Multiply by derivative of the first. Derivative of x is 1. Plus bring x, that's x. Multiply by derivative of the second by 2y. That's the product rule. You bring the second, multiply by derivative of the first. Plus you bring the first, then you multiply by derivative of the second. Can you hear me, r squared? Okay, let me just take this call so that it stops ringing. Hi, OGK, how are you? Yeah. Okay. Okay. No problem. Okay, no problem. I'll do that. All right. Cheers. Yes, tomorrow. No problem. Cheers. So now there's one last thing which I now need you to see. Which I now need you. First, I want you to see that we treat them as functions, which means when they multiply, you have to use the product rule. Are we together? This is where implicit differentiation is hard. People don't use product rule for this situation. That's the biggest mistake you can ever make. They are functions. X and Y are functions. And right now they are multiplying each other. And math says when you are differentiating functions that multiply each other, use the product rule. Product rule is for functions that multiply. So we used the product rule. What does the product rule say? That's part of it now. Okay? Product rule says when you're differentiating, you bring the second. So you let one be u, the other be v. Which means when you're now differentiating, you bring the second, you multiply by derivative of the first. Derivative of x is 1. Plus, it's so easy. You then say plus. Then now you bring the first, which is x, okay, the u. Then you multiply by derivative of the second. Derivative of y squared, you differentiate it just like you do x. Drop the power, it becomes 2y. But now every time you differentiate something with a y, when you're done differentiating it, you must then say dy dx afterwards. Are we together? When you differentiate anything with a y, you differentiate it the same way you do x. But the moment you differentiate it, right next to it, you must put dy dx. Okay? You have to, right next to it. So this part we have done very well. I'm proud of you. You have used the product rule for xy squared. That is very hard for people. You are doing the things that make implicit differentiation hard. So anyone can see an implicit equation to say, I can't make y the subject. There's a y squared, there's another y in here. I can't make y the subject. So it's implicit. So I'm going to differentiate it inside brackets. That's fine. But the problem now becomes when they start, because they don't treat this like product rule, and that's a disaster. So we have used the product rule. We've done very well. Bring the second, multiply by derivative of the first. Plus, bring the first, multiply by derivative of the second. And when you do derivative of anything with y, you should put dy dx straight after. We differentiated y squared, it became 2y, but straight after we put dy dx. And this is equal to now the derivative of 1. Oh no, before we do the derivative of 1, we are now doing this one now here. We are now doing this plus. So we now say plus. Remember, we are differentiating everything. We are differentiating. So now say plus. Now we are differentiating something that has to do with ln. Something that has to do with ln. Something that has to do with ln. Let me give you a tip. This is the tip, okay? Listen to this tip. When you are differentiating something to do with ln, here's what you do. Here is a rule. Derivative of ln, okay? When it's not, if it's ln x, the derivative of ln x is 1 over x. But when you are differentiating something which is ln, then it has many things. Like here, ln of x plus 2y. It's not just ln x. It's ln x plus 2y. When you are differentiating this, you ignore the ln. Listen to how you do it. You are differentiating something with an ln. Ignore the ln when you are differentiating. This is for differentiation. Ignore the ln. Look inside its bracket. What do? Differentiate the inside and divide it by itself. This is a shortcut which you should know. When you are differentiating anything to do with ln, you ignore the ln and look here. Then what you do, you differentiate that part and divide it by itself. So we want to differentiate ln of x plus 2y. That's the one we want to differentiate. ln of x plus 2y. So what do? You are going to bring it back, x plus 2y. Then you are going to divide it by the derivative of itself. So we divide it by we ignore ln. ln is now gone. We bring it back, then we divide by the derivative of itself. Let's differentiate it. We want to differentiate x plus 2y. We start by differentiating the x. It's easy to differentiate things that are adding. You start by differentiating the x, you get a 1. Plus, now you differentiate 2y. Remember, derivative of 2y is the same as derivative of 2x. Derivative of 2x would just be a 2. Derivative of 2y is just a 2. But after, you should say dy dx. After the 2, you must say dy dx. Because you have differentiated something with a y. And it will be equal to 0. Now, let me show you where you now take this to. Because you can now see that you have a dy dx somewhere here, and you have another dy dx somewhere here. So what we should now just do is we should make sure the dy dx are close to each other. Are we together? We should just make sure they are together. If they are together, then we can finish it up. So that is now the next job which we have, is just to make the things with dy dx be together. So here you'd say y squared times 1 need to be y squared, plus here x by 2y, it'll be 2xy, and you should put dy dx after that because it's a 2xy dy dx. Plus, now here we have it, x plus 2y divided by 1 plus 2 dy dx. Right, what you can do is, to make it easy so you continue, you can separate them. This will become x plus 2y. You are only allowed to separate if it's the denominator. If it's the numerator, sorry. So what you'd be saying is, you'd say, let me write it nicely. Maybe let's take it to the other side, maybe. Let's see. It becomes equal to negative of x plus 2y over 1 plus 2 dy dx. Then we take the denominator to the other side to multiply. So you end up having 1 plus 2 of dy dx is going to multiply y squared plus 2xy dy dx. And it's going to be equal to negative x plus 2y. Can you see this? Okay, make sure it goes to the other side to multiply and make it neat. So when you then multiply, 1 will multiply the whole bracket. So 1 will multiply y squared, you get y squared. Plus 1 will multiply 2xy, you get 2xy dy dx. Plus 2 of dy dx will multiply y squared. It becomes 2y squared dy dx. Are we together? Then you're going to have plus 2 multiplying 2xy dy dx. You're going to have plus, it becomes 2 times 2, 4, okay? Then by xy, it becomes 4xy. Then it will be dy dx all squared. And it is equal to negative x plus 2y. So now our job is to make dy dx be alone so that we can factor it out and you'll be having your derivative. Are we together? So that's the last job we have now, is to make dy dx be alone so we can factor it out and then we can have a derivative. Let me see here. Give me. What did you want to say? For when you differentiate things with an ln x, it is the derivative over itself. Is that what we did? Oh, that's where we didn't do correct. Yes, it's the derivative over itself. So this is where the mistake is. And that is why it looks long now. Okay, that's good. It's always the derivative over itself. So this is the correct. This is very, very correct. Is the derivative over itself. So you would say here you have done your product rule nicely, right? So Let's put it here. We have done our product rule and we are proud of ourselves because we know that for this we have to use product rule. So we've done our product rule. Now we are differentiating this thing with ln. You differentiate it. Let's differentiate. You differentiate x, you get 1 plus you differentiate 2y, you get a 2, but with dy dx. Then you divide by itself, which is x plus 2y. Okay, that's good. You ignore the ln. And this will be equal to, now you differentiate 1, you get a 0. So everything has been differentiated now. All right, now that's good. Now that's perfect. So all we have to do is to simplify because the answer should come out. It shouldn't be too much hard work. So you'd say y squared times 1, you get y squared, plus here x times 2y, you got 2xy with a dy dx after. Plus here you got the 1 plus 2 dy dx all over x plus 2y. This is equal to nada, 0. So obviously what we need to do is to get rid of the fraction so that we can finish it off, right? And if you want to get rid of a fraction, you can do it in 2 steps or in 1 step. That's still fine. You can do it in 2 steps by taking it to the other side first. And you have y squared plus 2xy dy dx is equal to negative 1 plus 2 dy dx over x plus 2y. So don't let me down. Make sure you remember how to differentiate ln, a big ln. Are we together? You're going to meet it. You're going to meet it as you keep going with your math. Even for those who want to do engineering, you now take this denominator to the other side. You have x plus 2y, now multiplying y squared plus 2xy. Are we together? Dy dx. And it is equal to negative of 1 plus 2 dy dx. Now, let's expand. X will multiply this whole thing. X times y squared is xy squared. Plus x times 2xy becomes 2x squared y with dy dx. Then plus 2y times y squared, it becomes 2y cubed. Plus 2y times 2, it becomes 4 x, then y times y becomes y squared. And you put your dy dx. Are we together? And it will be equal to negative of 1 plus 2 dy dx. If you want to expand, it becomes negative 1 minus 2 dy dx, like this. Now, your job is to make sure that every dy dx is next to each other. Are we together? Put all the dy dx's together and remove everything else. So we take this one, this first one, it becomes 2x squared y dy dx plus 4xy squared dy dx minus 2 dy dx. This is equal to, now everything is going to the other side. So it's equal to negative xy squared, then minus 2y cubed, this one. Then there's a minus 1. This minus 2 should become a plus 2, by the way. Excuse me, because it has come to the other side. Can you see that? Excuse me. Then now it's easy. Look what you just do. You factor out dy dx. Okay? You remain with 2x squared y plus 4xy squared plus 2 to be equal to negative xy squared minus 2y cubed minus y. Are you saying this? Then to get your dy dx, you just take these guys to the other side to divide. So you end up having your dy dx being equal to negative xy squared minus 2y cubed minus 1, all divided by 2x squared y plus, okay, all divided by 2x squared y plus 4xy squared plus 2. This is everything. You've seen it? This is going to be the derivative. You have found it. Okay. And now that you have found the derivative, you can now find what they need. Gradient of the curve at x0. So you now just come here and say, let x be 0. You now get your dy dx being equal to negative of 0 by y squared minus 2y cubed minus 1 divided by 2x squared by 0 plus 4 by 0 by y plus 2. And everything which has a 0 becomes a 0. We know that. So here we'll get negative 2y cubed minus 1 divided by 2, which is going to be equal to, are you seeing this? This is your dy dx. You need to find the gradient. You see? So here, then you get the gradient. Let me make sure I didn't make a mistake anyway here. Mm. Mm. Let me see. Um, yeah, you get an answer. What answer? What answer can we get here? 2y cubed minus 1 over 2. Is this the solution? Check in the marking can tell me. What? This is February, March 2025, paper 32. Paper 3, option 2. What is the solution there? This is number 2. Okay. Which means they told us where y is. Because we now know that we are at x0, right? So we now know that at x0, this is what we'll be getting, our dy dx being this. But now we need to know what is also the value of y so that we can come and put it in here. Do you understand? Because we want to remove this y. So we want to know, we've said let x be 0, but what about y? What will y be? Do you get it? So we need to know what y is going to be when x is 0. So we rewrite the original equation and we are going to find out what is y when x is 0. So it'll be xy squared plus ln x plus 2y is equal to 1. Now we say again, let x be 0 again. We will come and put it in dy dx so we find the gradient. But first we want to know what is y when x is 0. So it'll be 0 by y squared plus ln of 0 plus 2y. It is equal to 1, which means 0 by y squared will be 0. So you now have ln of 0 plus 2y is ln of 2y is equal to 1. And you want to find y. So you take e to the other side. You have 2y is equal to e to the 1. And you get y will be equal to e to the 1, which is just e divided by 2, because 2 will go to the other side to divide. So your y is e to the 2. You go and put it in here. It will be now dy dx. You say let y be equal to e over 2. So this means now that dy dx will be equal to negative 2 of e over 2 cubed minus 1 divided by 2, which is, you'd say it becomes negative. Okay, since there is a 2 and a 2, but it will be negative 2 multiplying e over 2o cubed is e cubed divided by 2 cubed is 8. And it's all over 2, which becomes now negative 2 into negative 2, 1. 2 into 8, that's 4. So it becomes negative of 4 of e to the cubed divided by 4. And by the way, this negative was affecting the whole thing. So it becomes negative of e to the 4. Then minus, it becomes plus 1, and it's all over 2. And now we have to get rid of this 4 by multiplying everybody by 4. So it becomes equal to negative e to the cubed plus 4 divided by 2. Can you see this? Is this the answer you got? One over 8, so there must be an 8 in the denominator. Let's see where it's going to be. E over 4. Okay, we should multiply everything by 4, including this denominator. Okay, so it becomes an 8. So it's like this. Isn't this the same as the answer you have? Good. Anyway, answers change, small things change, but the big things don't change. What you have learned is a lot of things here. You've also learned that when you're looking for gradient, you don't just let x be something, because now you have parametric equations. You must also let y. Right. Have you seen this? Okay. Let's see if they give you another question to do with differentiation in this paper. All right. So here we are being asked about the maximum points. This is another application of differentiation. Have you seen this? All right. So now we have to do the application of differentiation here to find M, which is the turning point, and to find this different point. So the first question is a bit of backgrounding. Okay, here is the first question, which is a bit of backgrounding. It says, please, by looking at this diagram and whatever else information is there, can you solve this by showing that P will satisfy half tan inverse of 3 over 2B? So we want to find out what this is about, differentiation or what? Are you seeing this question? The biggest question is, what concept will they be asking you when they give you a curve and they give you two functions multiplying? So if you ever want to solve this curve, you have to use the product rule. I've taught you to see it because x cubed is an algebraic or polynomial. Is it true? Then cos 2x is a trig and they are multiplying. So you use the product rule. Can you see that? Okay. Now, where is this point called P? P, can you see it's the point where you are at the maximum? So we need to first find out about the maximum, right? Then we know that P will be at that point. So first let's find that maximum. How do you find maximum? By differentiating, isn't it? So you're going to say your y is equal to x cubed cos 2x. Now you got to differentiate. So it's going to be dy dx. This is going to be equal to product true, product true, product true, because they're multiplying. This becomes u, this becomes v. And when you do the product true, what do you say? You say bring the second one, which is cos 2x. Then multiply by derivative of the first. Derivative of x cubed is 3x squared. Then bring the first one and multiply by derivative of the second one, which is going to be, oh, here what did we do? Bring the second, multiply by derivative of the first. Now you bring the first, which is x cubed. You multiply by derivative of the second now. You multiply by derivative of the second, which is derivative of cos 2x is going to be 2 sine 2x. It's actually negative 2 sine 2. So there we go. Now we have everything. And what we know is that this is our dy dx. Let's first finishing. This becomes 3x squared cos 2x. Then minus now 2x cubed sine 2x. Now you're going to say for stationary or for maximum point, whatever. For maximum, you say let dy dx equal to 0, which is going to be 3x squared cos 2x minus 2x cubed sine 2x is equal to 0. Are you seeing this? Now we can apply to deal with maximum and everything. We know that's how they will ask us for differentiation. There will be something they want to do with the derivative. But the first stage is, hey, you must know how to differentiate, how to do the product, how to do everything. Then now you start with application. So here you've made it equal like that. Now what do you do when you're solving? You would say, okay, this is now the trig equation to solve. Can you see it? So for this trig equation, if you want, you can have the x things divide each other. So in other words, you can say 3x squared cos 2x is equal to 2x cubed sine 2x. Can you see this? So now, what do we have to do? Let me put it like this. What do we have to do like this, to do here? Remember, we are going to have x, this one, BP. Is it true? X is going to be a P at this stage here, at the maximum. On the x-axis, we'll put a P. So you'd say, if I want to put a P there, we can even do the factoring out method, right? You would say, first let's divide the cube, the things with x. We're going to divide both sides by x squared. Which means here, the x squared will cancel. Then you get 3 cos 2x. And here, and this is how it goes. You now have 2x sine 2x. Now what do? You can take sine to the other side and 3 to the other side. So you will now have cos 2x divided by sine 2x is equal to 2x, which remains here, divided by 3. That 3 goes. Now, cos over sine is like 1 over tan, because sine over cos is tan. and this is 2x over 3. Can you see this? Good. All we are trying to now do, which we have done, is now to get to the final solution. Now remember that you say, let x be equal to p. You can see we are already beginning to get the tan inverse, which they were saying there's a tan inverse, there's a tan. Do you remember them saying that in the exam question? R squared. Yes, hi, sorry, how are you? Yes, on this number, it's fine. Bye. Pardon? No, this is him. Okay. R squared, can you hear me? So now we have let x be p. So that means you just have 1 over tan p is equal to 2p over 3. What did they say we must show? Show that p is half tan inverse. What? So we just have to make p the subject from here. So what would we do if we want to make it the subject from here? We say tan p over 1. We flip this side, which means we also have to flip this either side. It's 3 over 2p. Tan p over 1 is just tan p. And this is equal to 3 over 2p. The reason we knew you were removing is tan inverse is this one when you remove it. So now you have p be equal to tan inverse. Okay, it goes to the other side, becomes tan inverse of 3 over 2p. Can you see that? And they said show that it is half tan inverse of 3 over 2p. Ooh, where's the half? We left the half somewhere. Let me see. Oh, yes, this is tan 2x, not tan x. So if we say let x be p, this would be tan 2p. Tan 2p. You flip it, becomes tan 2p like this, which means this will be tan 2p. And you take p to the other side, the tan, I mean, okay? You remain with 2p, which is equal to tan inverse. Then you get p being equal to the 2 goes to the other side, it becomes half. Half tan inverse of 3 over 2p. There we go. So this is it. Can you see this? It was just differentiation and a bit of playing around. Um, Here now they are giving you another question, which is now saying, show by calculation that P is between 0.5 and 0.7. Can you see it? Okay. So we're going to have to prove that it is between 0.5 and 0.7, right? So what you should basically what happens is this. Let me say what you must have is this. If you choose a value, you must be able to get uh you must be able to get like a sign change for you to know that there is a value of p between them. Okay, it's like it will be like a sign change between 0.5 and 0.7, right? We call it in maths the IVT. Can you put it to say the intermediate value theorem? Okay, So all you have to do is prove that when you are going to get to put 0.5, you get a positive answer. When you put 0.7, you get a negative, or vice versa. One is positive, one is negative, which means P is between them. There is a solution between. Are we together? Okay, so that is all we have to do. So what we are going to say is, what do we have? You said P is equal to half tan inverse of 3 over 2p, right? Now, what we are going to do is we are going to feed in 0.5. So you say, let uh, the this p that we have, we'll call it like p of x. Let's say that, right? Let me say, isn't I have this p? I'm going to take it to the other side here, and I'm going to have 0 be equal to half tan inverse 3 over 2p, then minus p. Then this here is what, instead of 0, I'll call it f of p or something. The function, it is half tan inverse of 3 over 2p minus p. Are we together? Have you seen this? So you now say, let p be equal to 0.5. You get f of 0.5 is half. Just prove that. If they say show that there is a solution between them, just prove that there is a sign change. So what is half tan inverse of 3 over 0.5 minus 0.5? Can you punch this? Tell me, punch it exactly like this. Tell me what you get. Remember, you can put half in brackets if you want, since it's a fraction. All right, so you got 0.2028, right? All right, let's just say. Now, what about f of 0.7? If you say, let p be equal to 0.7, it'll be now half tan inverse 3 over 0.7 minus 0.7. What is that going to give? So can you see that there's been a sign change? Hmm? So because there's a sign change, you can say, since there is a sign change, that means we definitely have a solution between it. Between 0.5 and 0.7, we have a solution. Are we together? Good. Any question? We're looking for differentiation. You should be able to do many differentiation questions, right? Summer 25 question paper 3-1. Are you seeing this now? May, June 2025, last year. Can you see this? Let's see how they asked us to differentiate. There we go. Can you see this? You are ready for this, right? This won't shock you, will it? No, it can't. So let's differentiate it. You have x is equal to e to the tan t, which means we can get dx dt, right? We can differentiate x in terms of t, right? Now let's differentiate it. Here we have a problem because this is not e to the t. It is e to the tan t, right? So tan has put itself inside of e. Is it true? So that means we have to do the chain rule. Is it true? And chain rule says start by differentiating the outside without changing the inside. Then you multiply by derivative of the inside. So you'd be saying, let's differentiate the outside first. Let's differentiate the outside without changing the inside. This is the inside, the power, it's the inside. We differentiate the outside function. Both of them are functions. Come on now. E is a function, tan is a function. So we should differentiate them starting with the outside. You start with E. When you differentiate E, it doesn't change. You should go to the table. You will see that the table tells you that the derivative of e to the x is e to the x. So this doesn't change. So it comes back exactly as it is. When you differentiate e, it doesn't change. So you have differentiated the outside. But then you must now multiply by the derivative of the inside, which is the derivative of tan t. And the derivative of tan is sec squared t. That's the derivative. So now you have your dx dt. It is e to the tan t sec squared t. Then now we have y. Y is 3 tan squared t. And now you can find dy dt. Now we can find dy dt. Now we need to find dy dt. Now we need to find dy dt. How do you find dy dt? How do you differentiate tan squared? This is important. When you differentiate it, it's like this. Let me show you. Tan squared is actually, before we differentiate it, let's change it. It's tan t o squared. So the squared is actually outside. That's why you should practice a lot of differentiation, but this is easy. Dy dx now, we want to differentiate. This 3 doesn't go anywhere. Any number which multiplies is never affected by differentiation. So the 3 is like this. Let's do the differentiation of tan t o squared. This part, this tan t o squared. What do? We start with the outside, which this case, it is the power, because the power is just a number. It's not on the inside. So you start with the outside function. How do you differentiate the power? You drop it down, then it reduces by 1. Inside, it's still tan t, but it's now to the power of 1. Then you multiply by the derivative of the inside. That's the chain rule. Differentiate the outside, then multiply by derivative of the inside. So we now multiply by derivative of tan, which is again sec squared t. So you end up having 3 by 2, it becomes 6. 6 tan t sec squared t. Now we can continue to the next step. Those 2 stages that I told you, those two, now they are coming into play, because what you actually want is dy. This was dy dt, by the way. It's not dy dx. It was dy dt. Now you want dy dx, and dy dx you find it by saying dy dt, which you already have, that's not a problem, times dt dx. You don't have dt dx, you have dx dt. So you say this is going to be equal to dy dt times 1 over dx dt. So you can say now this is going to be, what is dy dt? 6 tan t sec squared t times 1 over dx dt. What is our dx dt? It is e to the tan t sec squared t. So it is 1 over e to the tan t sec squared t. This is what we have. Now you multiply a fraction by a whole number, the whole number just goes to the top. So you end up having 6 tan t sec squared t, all divided by e to the tan t sec squared t, where you just have sec squared t and sec squared t cancel, and you remain with it being 6 tan t divided by e to the tan t. Are we together? You have your dy dx by parametric means. Yeah. Now, did they ask you to find anything? Yes, they did. We know they will. They will not just say differentiate. They will ask you something to do with application. But you don't rush. You can't think about application when you don't have the derivative itself. So we are now allowed to think about equation of tangent. We are now allowed, because we have dy dx now, so we can start to use it to find different things. Now, how do you find equation of tangent? What you must know is that whether they say equation of tangent or equation of normal, they start here by knowing that tangent is a line. Even normal, it is a line. So it is in the form y is equal to mx plus c. Every line is in this form. So it was to make the equation by just knowing m and knowing c. That's all it needs. So here we want the equation of the tangent, but we must know m. So m is equal to dy dx. M is the gradient, which is dy dx, but it is dy dx at the point, okay? It is dy dx at with the point that you're told. Let's go to the point, to the curve at the point e comma 3. So at e comma 3. Dy dx at e comma 3 is the m. It is the m, which is great. So we can now say m will be equal to dy dx is 6 tan t over e to the tan t. Now, which means it would be m will now be equal to this here is x, this is y, right? Can you see? Okay. So it's like we have to put in the point. When we put in the point, we always feed in this one. This is the point that matters. Okay? Or if you want, let me tell you what you can do. This is not the point that matters, but since this is your x and this is your y, you can go to any equation, let's say here, and you find t by putting in the x, or find t by putting in the y. Are we together? That's why you see it having how many marks? 6 marks. So now you have to find t. Okay? You can write x is equal to e to the tan t. Now for us to remove tan t, we bring ln both sides. Ln x is equal to ln e to the tan t. Ln of e, the thing just goes. So ln x will be tan t, because ln and e cancel. So tan t comes down. Then you take tan to the other side. So you say tan inverse of ln x is t, because tan goes to the other side to be tan inverse. So you can now say tan inverse of, what is our ln x? It is ln of, what is our x? X is e. So ln e, this is equal to t. Are we together? This becomes tan inverse of, what is ln e? Put in your calculator, tell me what you get. You get 1. So now tell me, what is second function tan of 1? Pi over half, or pi over 4, which is 45 degrees. So you have it as pi over 4, which means now you can be able to finish it off because you have m. You have your t, which you can use to find m, right? So you now that you have t, you say m is equal to, what is m? 6 tan t over e to the t. So it is 6 tan t over e to the tan t. So now you say m will be equal to 6 tan pi over 4 divided by e to the pi over 4. Here it is e to the tan of pi over 4. What do you get? 6 tan pi over 4 divided by e to the tan pi over 4. What do you get as the answer? (2.2). Can you get it as a fraction? It's confusing. 2.207. I don't mind. So now you just have y is equal to 2.207x plus c. This is how you see. Can you see how you get equation of Italian? You gotta find m, and m is the gradient. Gradient at the point given. M is dy dx at the point, so it's so easy. Now you have your m. All you have to do is find c, right? And c is easy to find because you have x, you have y. So you just say let x be e and y be 3. So you have 3 is equal to 2.207 by e plus c, which you take them to the other side. 3 divided by 2.207 e is equal to c. What is the answer? What is the answer here? What answer do you finally get? 0.6091. Let's see. So it's 2.207x plus 0.6091. This is going to be a potential solution. Can you check for us what solution you get? You're supposed to have. Although usually A level uses fractions instead of decimals. This is number 4. Pardon? May, June 2025, paper 31. What is the solution? R squared? Okay. Say it again. Y minus E y minus 3 is equal to mhm, x minus E. So this is what you got. It's x minus 3, right? Really? So the only mistake we did was converting to decimals, okay? Here. Can you see here? We mustn't convert to decimals. The answer will find itself. What is tan pi over 4? What will you get? What is tan pi over 4? Isn't it like 1? So m is 6 over e. Because it will be 6 by tan pi over 4 is 1. And it will be e to the tan pi over 4, which is 1 also, okay? So it is 6 over e. Can you see this? So our m is 6 over e, okay? Can you see this? Then now we just have to find c. You say x is e, y is 3, then you find c. So you'd say 3 is equal to 6 over e of x, which is e again, then plus c, which now we can use it to find the c. E and e will cancel. 3 will be equal to 6 plus c, which means 3 minus 6 is equal to c, which is negative 3 is equal to c. So you would have it as y is equal to 6 over e x minus 3, okay? Can you see it? Can you see what we've done? So we'd need to just check again to make sure it looks exactly like this one. Let me see, x minus 3. Yes, this would be correct. Let me see. So this is the correct solution, right? This is what we have found. We are not far. Can you see that? Okay. Okay, so yeah, it's quite similar, okay? It's quite similar. It's pretty much the same answer. You can just leave it in the form that we have done it, okay? Don't worry about the correct. Because I saw what they did, but it's not necessary. This is fine. Okay? Yeah, we don't have to introduce -3. That's just what they did. They introduced -3 both sides, but it doesn't help anything. So leave it like this and you'll be done. Okay? Good. Anyway, this is it to do with parametric. So they brought you parametric and asked you to get this. Now, okay, so this will be the last, which is on um, two functions multiplying, and you have to differentiate them. I'll give you this as your assignment. Can you do this and send to me, okay? Differentiate this, let's see. This is number 11. I'll give you a tip. Y is cos x multiplying the square root of sine 2x. And you know that we don't differentiate anything with the square root. So before we start differentiation, before we start, you change the form. It should be sine 2x to the power half. Okay? And this is going to be your v, and this will be your u, and we start from there. Okay? Because they are multiplying each other. So you have it like this. So this is what you have. Then you can now do the product through and everything else. Are we together? Good. So do it. And you, obviously, because they've said the word maximum, you will let some point, you will let dy dx equal to 0, and you see what you can do there. This is important because it's at the maximum. So that is now application. Anyway, I'm happy. I'm proud. You have done very well. So now I'm dismissing you, okay? Good job. I'm proud. Is it making sense?